Hello and welcome to another video. In this video, we are going to discuss functions and accessing the help in Python. So you've already seen functions in action, right? You've seen the min function, max function, print function, type function. But Python has many more functions, and even defining your own functions is a big part of Python programming. In this lesson, we're going to get deeper on that. So, you've seen the ABS function or the absolute function. Now let's say I throw you a googly and say you have to use the round function. You don't know what the round function does. So a thumb rule of anything that you come across that you want to know has to be accessed through the help function, and the help function is a function where you can put in the Python function that you're interested in knowing, and that would give you access to what that particular function does. So if I run this, the environment will connect, and then the output will tell us exactly how round function behaves. So you see, the round function takes as input a particular number, and then an n digits equals none, meaning it is not a mandatory input. We'll learn all about that in a minute. And what it's telling us is this function rounds a number to a given precision in decimal digits. It was helpful. The return value is an integer if n digits is omitted or none. Otherwise, the return value has the same type as the number. N digits may be negative. So let's try and understand that with an example. So the round function, if I just say round of 10, I'll just get 10 in return, right? Because I did not specify the n digits function. What if I do this, right? And then access the round function again. It will give me the integer value of that number by default. But now let's say I want to round off this number to the first place of decimal. Then I just have to specify an additional parameter, and this is where the inputs can be 1 previously like we saw, or 2 in this case, right? So if I execute this, it rounds it off to the nearest decimal, the number of decimal places that I specify. And if I do that to 10.284, obviously the approximate value of that rounded off to first place of decimal is 10.3. So you just went from hearing the word round to actually accessing the help function, knowing what the definition is, even usage of it, and now you know what round function is all about, right? So essentially help displays two things: the header of the function, that is the name and the number of inputs that are required and optional. So like we just saw, the second one here is optional. Okay, so in this case, it tells us that round takes an argument we can describe as number. Additionally, we can optionally give a separate argument which could be described as n digits. Okay, and of course a brief English description of what this function does, like so: round a number to a given precision in decimal digits. Okay, now common pitfall: when you're looking up a function, remember to pass in the name of the function. That's it. So what I did here was I actually called the function. I did not specify the name of the function, which, by the way, was all I had to do. Okay, all I had to do was specify the name of the function in the helps input. But instead of that, I did an entire function call inside the help, and the output is not very helpful. Okay, so just keep in mind, instead of calling the function itself, you just have to specify the name of the function, and then you should be able to access the help. Okay, now Python evaluates an expression like this from the inside out. So first it calculates the function, the value of the function round, and then it provides help on the output of that expression. So essentially what went on previously was round of minus 2.01 will yield what? Minus 2, right? So let's just test that out quickly because it will only return the integer value. Now if I put a help there, it's like doing this. It's like help of minus 2, right? So if I execute help of minus 2, then I get back the original output that we got here, right? The same thing. So you only want to specify the name of the function while asking for help. Okay. Now we've seen the print function many a times, so let's just see and access the help on this. So print has a value, and then the next set of dot 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 means you can provide any number of values to this print function. There's no limit to it. After that, you can specify a separator, an end line, and rest of it again we'll get to know that later. It's not important. So if I were to provide an example, let's say UNP is a good institute, right? Now if I do this, then I get an output. Now notice that there are spaces in this output that I had not specified. Now let me just add a bunch of stuff more. So like I said, you can keep adding more stuff here to print. It doesn't matter whether it's a single input or 2 or 3 or as many as you want. So again, it integrates the whole thing very well. But now where the sep comes into the picture is basically when you want to specify a separator. So a separator is, how do I put together these pieces in one string? So if I want to print this, it by default takes space as a separator. But this time I'm specifying commas, and look what happens to the output. See, all of the inputs that I specified are now separated by commas. Okay. So those are some of the ways you can again access the function print. We've been using this for 2 videos now, but all of a sudden you have a different perspective altogether about the print function, right? So that's a cool thing. Now, enough of built-in functions. Let's take a different approach. Let's define our own functions. It's great. There's the print, type, min, max, abs, round, whatnot. Great. What if I want to define my own function that has my own business logic or my own functionality that I want to define a function as and then call that function whenever I want to? So in that case, what I have to do here is use the def keyword, def, short for definition. So I'll have to specify the def keyword, and then here I write the name of the function. Now keep in mind, this name should not be a name that already exists as part of the standard built-in functions of Python. So let's say I do this def type. Type is already a built-in function, right? So what it will do is overwrite the original built-in function to what you just defined, and the whole thing becomes a big mess. Okay, so just keep in mind to use a function name that is unique. Okay, so in this case I've named the function least underscore difference, and I want 3 inputs to this function. So I've specified A, B and C, 3 inputs, and then I put a colon. Okay, now after I'm done putting the colon, I will have to indent my code so that everything that is with this indentation resides as part of this function's block. Okay. So the only way I'm going to define what is going to come under the scope or purview of this function is purely by using indentations. Okay. So I'm saying I'm going to take the absolute value of a minus b, then the absolute value of b minus c, then the absolute value of a minus c, and store each of them in variables diff1, diff2, and diff3 respectively, and then return the minimum. Okay. So let us execute this. And you can see that it got executed, but nothing happened. Why? Because we've just defined this function. Defining a function is like what it is going to do if it is invoked. It's not invoked yet. So we're going to call it in the next block. Okay. So now we say print the least difference of 1, 10, 100. Now, if I do this, what is going to happen? This is A, B, and C respectively, right? So A in this case is 1, B is 10, and C is 100. Okay. So what is the difference between A and B? It's minus 9, correct? But if I take the absolute value, it just becomes 9. So diff1 is 9. Second, I do absolute value of B and C, or B minus C. So B and C is like so, minus 90, absolute value of that is 90. So diff2 is 90. And then I do A minus C, which is basically 1 minus 100, which in this case will be minus 99. Absolute value of that is 99. And I store it in diff3. And I take the minimum of diff1, diff2, diff3. So in this case, it will be the minimum of 9, 90, and 99. What's that going to be? It's going to be 9, right? So at least for the first instance, we'll see that the difference will be, or the output of this function will be 9. And in the second case, of course, you can take a guess. It's probably going to be 0 and so on, right? So the first output was 9, just like we had predicted. Second one was 0. Third one is 1. Okay. Now, if I access the help of the function that I wrote, right? So since this is a function that I have written, if I want to access the help, see that it's not being very helpful. It just prints the definition of that function, just the name and the inputs that it expects, but it's not giving me that English description and all of that, right? So basically Python isn't smart enough to just read your code and understand, okay, this is what your code is trying to do, so let me just cook something up in terms of describing it. It's not how it's going to work. So part and parcel of mitigating that is something called docstrings. So what we are going to do is, just after we have written the definition and just before we write our logic of what goes inside this function, we are going to specify a docstring in Python. A docstring in Python is basically a multi-line string that starts with triple double quotes and then ends with the same. So 3 sets of double quotation marks is what will go inside a docstring. And then now you can write what this function is going to do is basically return the smallest difference between any two numbers among A, B, and C. So that's a fair description. And then I'm even giving an example here of, look, if you call least difference with the numbers 1, 5, and minus 5, the answer here is going to be 4. Okay. So let's execute this. And what happened now, again, no output because we've only defined the function, haven't invoked it. What will happen now is if I try to access the help of this function, then I will now end up getting some very helpful descriptions. So up to this we've already seen, right? But this time, return the smallest difference between any two numbers among A, B, and C, and then even there's an invocation example that the user can find helpful, right? So, okay, I got the English definition, but how do I actually invoke the function? So it's a cool example there to kind of walk you through what is going to happen, right? Now, so we've done the def keyword, the function name, the inputs required for a function, and even docstrings, right? It's time to learn a very important keyword associated with functions that's called return. When you call a function, it is expected to execute a code block, but it is not expected to return anything as an output unless you explicitly specify. So here I can see everything is fine except there is no return keyword here. Okay, so if I go back, there was a return keyword here, but this time intentionally I've left this out. Okay, so what's going to happen here now is, if I try to print these three pieces of invocation, nothing is going to be printed because this function is not returning anything to be printed. Okay, so if I execute this, it just says none, none, and none, right? So the first time of we called that function, it returned nothing. Second time, nothing. Third time, nothing. Okay, so what you essentially have to do is make sure that if you really want to print the above, then you'll have to define it with the return keyword. And now you will see we are back to getting 9, 0, and 1, right? So that's an important thing to keep in mind. Okay, now without a return statement, obviously the least difference function is completely pointless, but a function with side effects may do something useful without returning anything. Okay, so what that means is, we've seen examples of print, we've seen examples of help. They particularly don't return anything, they just print stuff on the console, right? So let's say if I take a function invocation of a print and try to store it in this variable and try and print this variable, see what happens. Nothing. Okay, so the least difference function that we wrote was completely pointless without the return keyword, but there are functions like print function that does not have a return keyword, but they are completely useful. Okay, so I just wanted to compare and contrast an example where the return keyword is very important and in other cases not so much. Okay, so that's the explanation. Okay, so again, we've gone through some of this, like the sep here. So if I specify the separator as this, what is going to get printed here is 1 less than 2 less than 3, right? So we've seen this before, and there we go. Okay, by default, if you don't specify this, the sep input is actually a space. So you'll see 1 space 2 space 3, like so. Okay, so by default there's a space in between. Now we come to discuss optional parameters. This is something that we have seen in the round function. The n digits parameter in the round function was an optional parameter. What this means is, I do not expect you to give me an input mandatorily. It's optional for you. If you don't give it, I'll manage, right? So what is going on here? Let me write a greet function which will basically ask for an input who, because the function wants to know whom to greet. So I specify an optional parameter called who, but the way I define it as optional is, I'm telling Python that if the user does not specify the value of this who input, you just go ahead and take colon by default. Okay, so what it will end up do is just print hello colon. Okay, so if I invoke greet here, then it will just say hello colon, because I did not specify whom to greet. But then here, if I say greet who equals Kaggle, then it will say hello Kaggle. Okay, and then in this case it will say hello world. So again, hello Colin, hello Kaggle, hello world, just like we had anticipated, right? Now, it turns out that functions being first class citizens in Python, you can call functions that call other functions, or you can define functions that have function definitions inside of them. So it's a little bit of a nested structure that is also possible here. So it is powerful, and it can be a little unintuitive to understand in the beginning, but once you stick around, you'll just understand what we are talking about here. Now this is a vanilla function. We're used to this by now, right? So there's a def keyword, function name, input to the function, colon, and then everything inside that indentation is the scope of the function, and we just return 5 times x. So whatever number you give me, I just multiply it by 5 and give it back to you. Okay. Next, I have a call function, def call. It takes 2 inputs, a function and an argument. And what it is doing, it's basically going to call that function with that argument. Okay, so what do I mean? Let's define another function called squared call, where this time it is calling a function with an argument and again calling that function. Okay, this will all get simplified with the help of an example. Now, what is going on here is, if I call a function like so, the function call expects a function and an argument as input. So I'm giving it a function, which I've defined over here, a function and an argument. So what this will do is, so if I just trace back through the call stack, so once I call this particular function, what it will do is this, functions and arguments, right? So what is function in this case? Multiplied by 5, and then what is 1 here? The argument. So this function just played the role of a proxy for calling this function. Okay, so when I say call mult by 5 comma 1, what it essentially did was, it is returning the output of this function call. So now mult by 5 function will be invoked with 1 as an input. So 1 times 5 times 1 will be 5. So a 5 will get returned, and the output of this line will be 5. Okay, same thing. If I do squared call, then what is going to happen? A squared call is basically the function of an argument, right? So the function is multiply by 5, and the argument is 1. Okay. Now what is going to happen? This code will get executed first. So this will return an output of 5, and then 5 will get fed as an input to another call of mult by 5, and then 5 times 5 will be 25. So the output of this second call will be 25, and then the separator is a /n, which essentially means a new line. So it'll just go to the new line and print it one after the other. Okay, so if I execute this, the first is 5, and then it goes to the next line and prints 25. So that's the way this whole thing works. Now, functions that operate on other functions are actually called higher order functions. So in this case, the call function is actually a higher order function. You won't probably write your own for a little while, but there are higher order functions built into Python that you might find useful to call. Okay, so let me give you another example using the max function. Now by default, max function returns the largest of the arguments, obviously, right? But if we pass in a function using the optional key argument, it returns the argument x that maximizes key, aka argument max. Let me again break that down. Don't worry if this is becoming a little confusing. I'll help unravel everything. Okay. So again, there's a function called mod underscore 5. What is it doing? Not important, but it's taking x as an input and returning the remainder of the division by 5. So go back to the first video. This is the modulus operator. Okay. So it returns x percent 5. That basically means if I feed 23 as an input, it will just return 3 because that's the remainder when you divide that by 5. Okay. Now, let's say which number is the biggest. And I simply invoke the max function of 100, 51 and 40. Okay. What will this yield? Obviously 100, right? Now, which number is the biggest modulo 5? Okay. Which number is the biggest modulo 5? It's a very interesting question. What this question is asking is basically which number among these three returns the highest value of the remainder when divided by 5. Okay. And that is getting specified when I say key equal to mod underscore 5. Okay. So when I say key equals mod underscore 5, that essentially means, find me the max of mod underscore 5 of 100, comma, mod underscore 5 of 51 and mod underscore 5 of 14. Okay. So I'm basically calling the key, specifying the key as mod 5. So what will happen is the mod 5 function will get applied to each and every one of these numbers, and the output of these numbers will then be considered by max. Okay. So what will this result to again? This will result to max of, what is the mod 5 of 100? It's 0, right? And then what is the mod 5 of 51? It's 1. And then the mod 5 of 14, it's 4, correct? And what will be the max of, and then what will be the max of 0, 1, 4? It is 4. Now this essentially means the 4 should have been the output, right? Wrong. So the 4 is the highest among this, but it is the third position of this max function, right? And what was it the third position originally? 14. So this will return 14 as the max. So even though we know that among these three, 100, 51 and 14, 100 is the highest, if I just change the key, I'm essentially changing the criteria of evaluation. So I change the key, what will happen now? This gets invoked, and then instead of returning the number 4, which is the max in this case, it returns the number that was in this position originally as the output. Okay, so if I execute this will return 14 at the end. Again, I tried my best to explain what is going on here. Should probably rewind that, watch a couple of times till it starts making sense to you. Or even if it does not, I promise you, once you tread down this road and keep going, things will definitely get simpler. So that was it in terms of functions and getting help. Thank you so much for your time.